Welcome to another video of Math with Jonas, where I try and take the complicated and make it much more simple for you. Today we're going to be looking at multiplying polynomials, but I'm going to show you a little trick I like to use. I especially like teaching it to people who either are trying this for the first time or have tried this and get very confused by what's going on. And if you can draw a box, you can do this trick. Before we get started, shout out to all my math people, all my math students who, when given a set of instructions, you might look at it and go, huh? Even though they're staring you right in the face, you go, huh? I just tried, I tried earlier today, I just got a French press, and I tried making some coffee with it, and it comes with the instructions. Unfortunately, no words, just these little pictures. And I was like, I got to Google this later. I got to research what these instructions mean later. I have no idea. So I walked to my fridge. I grabbed a can of coffee. It was delicious. And we try again tomorrow. That's the key. The moral of the story is we try again. With coffee, I got to wait till tomorrow because I don't want to have a whole coffee right now. All right. Let's jump into multiplying some polynomials. We've got 6 examples today. I'll leave timestamps in the description for each one. Our first one is just to, I want to introduce the box method that I like to use. I want to introduce it to you and really solidify the idea of what is going on exactly when we multiply polynomials. And then the other examples, we'll just get straight into it with variables and the like involved. All right, so in this example, we have something like 2 plus 4 times 7 plus 3. And yeah, sure, you can add these numbers and then just multiply them, but that's not what we're doing here. So we're going to visualize this problem that you see on the screen in a box. So you don't have to be perfect when you draw a box. As you can see, I am not perfect myself. All right. And let's start with this first parentheses. It says 2 plus 4. So I'm picturing this is a building, and we're going to put in some rooms and walls and hallways and whatever. But this the first side of the building is 2 plus 4. So let's go about 2 units down. If you're on top of your mental math, you should be going a third of the way down before marking this off as 2. And the other section here will have a length of 4. And up on the other wall, the other long wall, split up into 7 plus 3. So we go about 70% of the way in. And if you're trying this at home, don't worry. Your boxes don't have to be precise. I'm going a little bit overboard with it. The truth is, it doesn't matter how you draw your boxes. You can draw them however you want. As long as you have the right number of boxes and the things labeled in the right place, it doesn't matter what your boxes look like. All right, so we've got the length of all these. We got the whole building, but we got the length and width of all these little rooms. So what we're going to do is find the area of each of these 4 rooms or each of these 4 boxes. If you feel like you're one step ahead of me and you want to multiply it out first, you can always just pause this video, try it out, and then resume. All right, let's go. So in this first box on the top left, it's a 2 by 7 room. So we multiply 2 times 7, and that should get you 14. Now you can fill out these boxes in any order you want. I'm just going to go to the top right. This room is 2 by 3, so we do 2 times 3, and that gets us 6. Let's go to the bottom left. Now this room is 4 by 7. So 4 times 7, and that should get you 28. And our last room is 4 by 3, and so we do 4 times 3. Try that 3 again, and we try again. Okay, we're going to accept that that's a 3, and 4 times 3 is 12. All right, so basically our original question is like, well, if we have this whole building, and on one side it's 2 and then an additional 4. And on the other side it's 7 and an additional 3. What's the area of the whole building? And so we want to add, we've got 4 numbers in here, 14, 6, 28, and 12. We want to add those all together. You can add those in any order you want. I'll show you how I would do it. So I'm going to take 28 and 12. 8 and 2 are nice numbers to add. So let's add 2 to 28 and we get 30. And then we add this extra 10, we get 40. So we have 40 so far with those 2 numbers. And then we can take these 2 numbers here. 14 plus 6 gets you to 20. And remember, we're finding that total area, so we're just going to add all of this together. 40 plus 20 makes 60. So if we go back to our original expression, 2 plus 4, the quantity of 2 plus 4, times the quantity of 7 plus 3, well, that gets you 60. Okay, so hopefully the idea and the box method make more sense. And as we continue, it should further keep making sense for you. All right, so in this example, let's look at how it works when we've got some variables. Let's jump right in. So we got the quantity of x plus 5 times the quantity of x minus 1. And our goal is to simplify this as much as possible. We have no indication of what x would actually equal right now. So the most we can do is simplify it and put it in a format that sometimes is going to be more helpful than this one it's in right now. So let's go ahead and set up our boxes. Now you don't have to use the boxes. A lot of people will use arrows, and I'll show that a little bit later. But if you're using the box, okay, our first parenthesis says x plus 5. So we have x here. And let's make a hallway. And then on the other side of the hallway, there's still 5 more units to go. So we write 5 over there. And on this, the top part of our box, we're looking at this x minus 1. So we split it up into x. Well, that's a curvy hallway. And then on the other side, notice that I'm writing minus 1. Minus 1. So it says minus 1. We're writing negative 1 over here. So pay attention to your pluses and minuses. Now in this first box, it's x by x. So we do x times x. And that gets you x squared. So just like if you were doing 3 times 3, you could say that's 3 squared. Same thing here, and we kind of have to do that because we don't know what number x is quite yet. And we're not going to in this one. Okay, let's go to the bottom left. This is 5 by x. So we do 5 times x, and that's just 5x. That's the short way of writing 5 times x. Let's go top right. This is x by negative 1. Positive times negative makes negative. X times 1 is just x. So we got minus x. Over in this bottom right box, we've got 5. So 5 by negative 1, 5 times negative 1. And positive times negative makes negative, and 5 times 1 is just 5. So we're going to end up with minus 5. Now, what we want to do is write all this stuff. We're going to add all this stuff together, but let's just write it all out below here. So in my top left, I've got x squared. In my bottom left, we've got positive 5x. So I'm going to write positive 5x. And if we go to the top right box, we've got negative x. So I'm going to write negative x or minus x. And in the bottom right box, we've got minus 5. So again, just going to write minus 5. That's what's going on. Could I have written plus negative 5? I could have. Just put more symbols on your paper. It comes down to minus 5 in the end. But you could have done that. And now you're going to be asked, if you're doing this in a math class, you're going to be asked, okay, fully simplify. Fully simplify. So we've done a lot of the tough work. So I look at x squared here. I don't see any other term here that says x squared or anything like that. So we'll just copy that down. Now if we look at these terms, we've got plus 5x and minus x. So those are both x terms, also known as like terms. So you're allowed to add and subtract those or combine them. So positive 5x minus x, That gets you 4x, or positive 4x. So I'm going to write plus 4x, and you'll see this minus 5, there's nothing we can combine with it because everything else has an x with it. This has x squared, this has x, this has x, so we just got minus 5. And that's about all we can do with this. So if our original thing, x plus 5 times the quantity of x minus 1, gets you x squared plus 4x minus 5. Okay, now in this example, we're starting with an x squared term. So we'll see what that looks like. And just so you know, I don't have a good button on the computer for exponents. And so I have to go in and manually write in my exponents before recording. So if you're looking at all my exponents and going, wow, why do those look so funny? That's what's going on. All right, so we got negative 2x squared minus 3 times the quantity of 6 plus x. So again, let's set up the box. Yeah, good enough. Our first term here is negative 2x squared. So we're going to write that over here. And of course, remember, if you want to try and set up this box before I get going here, you can pause the video and then check your work with what I do. I'm going to clean this up real quick. That got a little bit messy. Okay, so let's try that again. Negative 2x squared. And then I've only got 2 terms, so I can just split this down the middle. And then minus 3. So we're going to include that negative sign. And on the other side, 6 plus x, so we have 6. And plus x, so positive x, or we could just write x. In this first box, we've got negative 2x squared times 6. Negative times a positive is negative. 2 times 6 is 12. Times x squared. We can just tack that on at the end. So we got negative 12x squared in that first box. Let's go to the top right. Negative 2x squared times x. Remember, when you're using this, you can, if you get stuck at all, it's like you're finding the area of each room. It's just length times width for each box. And you've labeled all your lengths and all your widths. Okay, so negative 2x squared times x. Well, nothing's going to happen with that negative 2. And x times x is what all that is, so we can write x cubed. So negative 2x cubed. On the bottom left, we've got negative 3 times 6. Negative times a positive is negative. 3 times 6 is 18. And on the bottom right, negative 3 times x. And you can simply just smush those together because that's how we write, whoops. That's how we write that multiplication. Negative 3x. Okay. So now we can write out these terms. And the way I write them out, I think it might be a standard form. Probably is. But I always start with the x to the highest exponent. So whatever box has the highest exponent of x, I start with that, and then I count down. So I'll notice in that's the first one's in this top right box. So negative 2x to the third power, that's the highest exponent. So down here we can write negative 2x to the third power. The next highest one I see is this negative 12x squared. So we're just going to write it like we see it, minus 12x squared. And over here on the bottom right, that's x to the first power. We're going to write it like we see it, minus 3x. And on the bottom left, we have this minus 18. And I'm going to write minus 18. And you might be asking yourself, well, last example, we added some of this stuff. Well, look at our terms. This is an x cubed term, or x to the third power. This is an x squared term. This is just x to the first. And this doesn't have an x, or if you're one step ahead, it's x to the 0. So none of these are like terms. This is our answer. So if we were asked to multiply this out and simplify, this is what we would get. And we wrote it in the proper form of is it descending? Our exponents are going down, that form. All right. Okay, so now we're going to take a quick look at an example. Not too much changes, but this one has 3 terms in a parentheses. So how does that affect everything? And again, for this one, I will show you with the box. So I'm going to start off like that, and I think I'm going to put the one with 3 terms up top. So I'm going to make this a little bit longer than normal. And as a reminder, if you do want to try this out, if you think you're a step ahead and you want to try this out before seeing me go through it, just pause the video, try it out, and then you can compare what you did with what I got. So here on the left side, let's split it up into x and minus 4. Zoop. And on the top, we got 3 things. So x squared. Make sure I have enough room to write stuff. Looks good. Our next term is positive 9x, so I'm just going to write 9x. We typically don't need to write the plus sign when something's positive. Typically, you want to include the negative sign to show that it's negative. And again, give ourselves some room. And then over here, we have minus 12. So we write minus 12, and now we can start multiplying inside our boxes. So this first box is x by x squared, so we're going to multiply the length and width. We're going to do x times x squared. And remember, this is just like 1 times 1 times 1, or 1 to the 3rd power. Same idea. So we're going to write x to the 3rd power here. Let's just go to this next box here. We've got x times 9x. And that's just going to equal 9. And then count how many times you're multiplying x. Here we've got x times x. That's twice. So we got 9x squared. And on this last one, we have x by negative 12. We can just smush those together and write minus 12x. Because when you write it in this format, if you don't know, when you write it in this format, this says negative 12 times x. We just shorthand form and leave out the times symbol. Okay, in the bottom left, minus 4 by x squared. Similar idea, you can just smush them together, minus 4x squared. Over here, we've got minus 4 times 9x. So minus 4 times 9x. And first thing I think about, negative times positive, that's negative. 4 times 9, that's 36. How many times am I multiplying an x? Well, we just have this one x here, so we'll just tack it on there. In our last box, it's negative 4 by negative 12. So we're going to multiply negative 4 by negative 12. A negative times a negative makes a positive. So I know my product is going to be positive. So now we can just do 4 times 12. And that would get you a nice, neat 48. Okay, so now we've got all kinds of stuff. We've got 6 terms in our boxes. We want to write it out. And just like the last problem, we are going to write it out with starting with the highest exponent, and then we're going to just count down. So first one we got here is this x cubed. And that looks like it's the only one that's to the 3rd power. So let's just write that out, x cubed. And I see a 9x squared. Not x squared, no, but I see another one here. Notice I'm going to circle the sign. That's part of it. So we got positive 9x squared. And minus 4x squared. So we're going to write it like we see it in the boxes. And we'll combine those in a second, but let's keep writing this out. So now we have our x to the first terms. That's these two here. So minus 12x. Minus 36x. And again, just writing those out like we see them. And then finally in this last box, we just have our normal number plus 48. Okay, so now what we're trying to do is combine our like terms. So our x terms that have the same exponent, or in some cases, like if we just had some plain simple numbers like 48 and we had some other ones, we can add and subtract those too. So here, let's go ahead and figure out what our like terms are. We have plus 9x squared. We have minus 4x squared. Other like terms we have are minus 12x and minus 36x. And because we wrote this all out in a certain order, that's why these are all next to each other. Otherwise, you got to do a little bit more searching. And so let's simplify. Here, x cubed, nothing to combine it with, so we just write x cubed. 9x squared minus 4x squared. So we do 9 minus 4, which is positive 5, so plus 5. And they're like terms, so we just tack on that x squared. And now next we have minus 12x minus 36x. And I know taking a negative number and subtracting can be a little bit confusing for some people, and that's okay. The way I like to think about it, I've got minus 12 minus 36. We're going to throw in the x in a second, but I've got minus 12 minus 36. If you're $12 in debt, and then you go another $36 in debt, how much debt are you in total? Well, we can add these two numbers together. 12 plus 36 is 48. So you're in debt 48 bucks. Well, assuming they're bucks, but you're in debt 48 something. So we write minus 48. And of course, we're going to stick on the x. That's minus 48x because those are the like terms. And then here at the end, we can write plus 48. And it might be tempting to just make this ending, like just make it 0, but this is an x term. This is not an x term. We can't add those together. Same thing, we can't mix these two. This is an x to the second power term. This is an x to the first power term. So we're not allowed to add or subtract those right now. Long story short, if you do, you're breaking the order of operations. And so our final simplified answer is x to the third power plus 5x to the second power minus 48x plus 48. That's about all we can do with this one. Okay, we've got two more examples to go. This is the beefiest one. Our last example, the one on the next page, is just, it's only got variables in it. So not even a single number if you are curious about that. But otherwise, this is the beefiest example that we're going to look at today before we look at the all variable one. So you'll notice we got 3 terms in both sets of parentheses. Now I'm going to set up the boxes in just 1 second, but if you prefer to use your arrows, I'll show you what that looks like in this example. I'll set up the arrows, but I'll do all the multiplying in the boxes. So if you're using your arrows and you don't want to set up your boxes, you're going to take this first term, and it's positive x squared. And you're going to multiply it by everything in the other parentheses. So 1, 2, and 3. And that's going to get you 3 different terms. So you multiply and write out your terms. Then you're going to take this minus 2x, include the minus. So when you're multiplying, include the minus. Just treat it like negative 2x. And again, you're going to multiply it with 1, 2, and 3 things. So it's like you're multiplying every combination of stuff from the first parentheses with everything in the second one. And then lastly, since there's a third term, you have to take this minus 8. And again, multiply it once, twice, and 3 times. Okay, but what I'm going to do for you is I'm going to set up the boxes for you. So let's go ahead and set that up. And I'm going to go a little bit quicker with the multiplication in this one. But let's set up our boxes. So in that first parentheses, we have x squared minus 2x. And you know what, let me make this a little bit bigger on myself. Okay. And our last term here is minus 8. And we'll do the same thing up top. We have minus x squared positive 3x and our last thing in the second parentheses is minus 5. Okay, let's dig in. So in this first box, we have x squared by minus x squared. That's going to be a minus. Think about how many times you're multiplying x. Squared and squared means you're multiplying it 4 times. So it's x to the 4th, or all in total minus x to the 4th. Make that a little bit more of a 4. Kind of looks like a field goal. All right, it's a 4. We continue. We march on. So x squared times 3x. Well, we're just going to have 3. How many times are we multiplying x? Well, we have squared and x to the 1, so that's 3 times in total. Over here, we got x squared times minus 5. Minus 5, x squared. You can just smush those together. Okay, in our middle row, minus 2x times minus x squared. Negative times negative makes positive, so we have 2. And we're multiplying x 3 times, so 2x cubed. In the middle box, we have minus 2x times 3x, so that's going to be negative. 2 times 3 is 6. X times x is x squared, so we get minus 6x squared. And in this last box, negative and negative makes positive. 2 times 5 is 10. And we do have an x hanging around. We have a times x, so we'll just tack that on there. And lastly, in the bottom row, negative and negative makes positive, so we have 8 times x squared. Smush them together, we get 8x squared. And in the middle of the bottom, negative 8 times 3x, going to be negative. 8 times 3 is 24. And then we can tack on that x at the end. And lastly over here, finally, no variables. Minus 8 times minus 5, that's going to be a positive. 8 times 5 makes 40. All right. So now what you can do, one little trick, you can simplify things on the go. But again, let's start with our highest exponent. So we have minus x to the 4th. You'll notice that none of the other boxes have x to the 4th, so there's nothing we can do with that. So now let's start looking at anything that has x to the 3rd power. I see one here. I see another here. Do we have any more than that? No, so just those two. So we have positive 3x cubed, positive 2x cubed. So we want to add these. Remember, it's like finding the area of a building, and we found the area of all the individual rooms. So we just got to add them up in order to get that total area. Very similar concept. So if we add these up, we get positive 5x cubed. Now let's look for any x squared terms. So we got 1 in here. 1 in here, 1 over here, and it looks like we got those 3. So you can add or subtract these in any order. Here's what I would do. We've got 8x squared minus 6x squared. So 8 minus 6, that's going to be 2x squared. And then we also have this minus 5x squared. And 2 minus 5 should get you negative 3. So down here I'm going to write minus 3. And then we can tack on the x squared. Now let's find our x terms. And let me just circle these in a different color. So we have a 10x and a minus 24x. So we have to do, let me go back to white here so it doesn't look that funny at the bottom. So we have 10 minus 24. And that's going to get you negative 14. And we'll tack on that x as well, because these are x terms. And then the last thing we have, I think, is just this positive 40. And nothing to combine it with, so we can positive 40, we write plus, and then 40. Whoo-wee. So that was quite a beefy example. Lots of stuff going on. If you're ready to practice and seeing this with only variables isn't that big of a deal to you, you can skip to the end of the video. There are some practice problems you can try out there. Let's go ahead and look at this last example. We got something very hypothetical, lots of variables, a plus b minus c times the quantity of d minus e minus f. And really this example is to show you that you can still do everything we just did, even if you don't have a single number. So let's go boxes. We've got a plus b. And then minus c. So we're going to make that minus c. Oops. I keep oh boy. There's a little button on the I'm writing with a pen. There's a little button on it that does erasing, and my big fingers always bump into it. Okay, so we're going to split this up. I know I've got 3 terms, so we're going to make 3 different sections. And we've got d minus e and minus f. So when you multiply 2 variables, you just kind of stick the letters together. Pay attention to if it should be positive or negative. So here we got, oh, there I go, doing it again. Okay, so here we got AD, and then we got negative AE. And I typically, like, what order do I write the letters in? I typically just write them in alphabetical order. Negative AF. Kind of funny. BD. Over here is negative BE. And here again is a negative BF. In our bottom row, negative CD. This one's going to be positive because both are negative. And we got CE. Same thing here. Also going to be positive CF. And if we keep things simple enough, none of these are like terms because none of them have all the same variables, meaning this has A and D, and if you look at every other box, nothing has exactly A and D in it, and that's for all of this. So if we wanted to write this out, we would have AD minus AE minus AF, and you can see I'm just writing out everything from my boxes plus here's the second row, BD minus BE minus BF. And our third row, minus CD plus CE plus CF. Wow. That's a chain of stuff. That's a chain of math stuff. If you ever do run into that though, you will know what to do and you'll understand that regardless of what's in place instead of the variable, that this process still works. Anyways, I hope you enjoyed this video. I hope you can multiply polynomials like a professional. If you liked the video, leave a like. If you want to see more of what I do, click that subscribe. And if you got any ideas for a future video or anything you'd like to see me do, you can leave it in the comments below. And I'll see you on the next one.